tradition of our teachers. And now these days, if we are very hard, so you see the classrooms.
So sorry, I have something to add this, but I have to write. Because this discussion reminded me the following story.
Tell him Chidumi's story. That is the best story. Charles Chidumi.
Someone knows this name. From graph theory, if you study, this is a Netherlands mathematician. He is still alive. I guess he's still alive. I'm not sure now. He constructed this famous algorithm. It's in graph theory. And it is about how you have a network, let's say, of cities, and you want to go and to visit all these cities, and you should do the shortest path, or maybe the shortest petrol consume, or any other things. And he was working in the what should be now Department of Computer Science, but it was in the 60s when it was no computer, just the first computers. He was the only one to work there. And he was studying this problem, how to solve, how to find an algorithm. And he's telling the story. He was engaged, and his girl, he took him for shopping. Generally, men do not like shopping, and ladies, they like very much. So for me, it's valid. I'm very unhappy when I have to accompany my wife for shopping. They would spend 10 hours in the mall, and I would spend 10 or 15 minutes, so no more. And he was accompanying his fiancée, and of course, when it's fiancée, you should be very, very gentle and very cautious. And after doing a lot of shopping, he was extremely tired of shopping, and he sat in a coffee and having a coffee. And he confessed, 20 minutes, he found this famous algorithm. 20 minutes. He was just had the, how to say, illumination. He just, but he was thinking about this long time. And it was just in front of the coffee, he realized this is the algorithm. Please check and see, it's a nice story. So this is the answer. We cannot give some recommendations. So it's particular to any person, how to do research, how to discover something.
Tell him about this ICTP. Yeah, that is good example. They can understand very well.
Which one?
Chidumi.
Chidume?
Yeah.
What about him? Which?
His student story. How he is training the students.
Oh, good. I had a good friend, and I told you about him. Chidume. Chidume. Very strong mathematician. I told you something about, but yesterday evening I told Professor Murthy my experience with him and his scholars, MS and PhD scholars. I visited him in Nigeria, and he invited Takahashi, Goebel, Reich, me, and some other, and only me, there to go to Nigeria. I said, no, we don't go to Nigeria, it's very dangerous. I said, I have no any problem. I went to Nigeria, and I enjoyed this. And we had a class. I gave a course to his students, not more than 7, 8, or 10 students, mainly PhD students. And I presented some of my ideas, And one day, after a few hours, I taught these students, he came in the class. And he told me, Vasile, I want to show you what are we currently working. And he went to the blackboard, it was blackboard, and he was speaking about what I mentioned, duality mapping. In a Banach space, instead of inner product, we have duality mapping and something else. And he introduced this concept of demi-contractive mapping in Banach spaces. And he started, let us consider uniformly Banach space. What is a uniformly Banach space? Don't tell me you don't know. Okay. I need the concept of duality map. What is a duality mapping? Tell me immediately. Go to the blackboard and write. And this was his style. But believe me, his students were all bright, very well, working all night. Some of them, I could see the room and the lights. I was alone in Nigeria. I could see they were working hard. So this was very kind. This was Chidume.
Hard training paves a mode.
So it needed hard work. So he did this very nice. So he put them to work. I'm very kind with my students, unfortunately. I said, are you interested to work? Okay, work. If you are not interested, I don't force you. But in that case, the problem was he offered them fellowship, scholarship. So they were paid for that. So, and that was the reason he put them to work.
One more question. Thank you very much for your inspirational words. So I would like to ask with Professor Murthy, just highlight about the contraction, contractive, expansive, non-expansive, and quasi-expansive. What? Just highlight a little bit about contraction, contractive, expansive, non-expansive, and quasi-expansive, so that we can understand easily.
I think quasi non-expansive map already he explained.
Yeah.
You remember? If you start with the Lipschitz map, from there only you have to start drawing when it is a Lipschitz map, then come to the contraction map, then come to the non-expansive map, then you remove one more condition, you have a contractive map, and what he has defined on the left hand side, that is the quasi non-expansive map. And when a quasi non-expansive map is a non-expansive map. So these are all the conditions. You have to start with the Lipschitz. Yeah. So in Lipschitz, L is greater than or equal to 0. In other, you can see that only coming up to the Banach, you have the constant. After the Banach, then you see the scenario. In non-expansive, there is no constant, means it is 1. And in contractive, it is strict condition, but that is not true for all values of x and y. You have to put condition on contractive map for x not equals to y, which is given by the Adelstein.
Okay, thank you. Thanks.
Sufficient condition is there for quasi non-expansive, blind non-expansive, anything is there?
No, I mentioned this. Here are non-expansive.
No, not table. Under what sufficient condition?
Okay, this is what I say. So, these are quasi-non-expansive. And here are non-expansive with fix of T non-empty. So, and here are non-expansive with fix of T empty. So this is the relation. If it's non-expansive and has fixed points, then it's quasi non-expansive.
Yeah, if you restrict to the set.
Yes.
Then it's trivial. Any other non-trivial?
I don't know that. So that's important because we don't care about this class of non-expensive mappings. They are not interesting for us. So in fact, we are interested only for non-expensive which have, so actually quasi non-expensive. This is.
Like clear or?
And lot of works now these days are quasi non-expensive. Yes.
Sir, I have a question. Sir, like us, are you facing the problem like similarity and index with the other papers? Because most of the journals are asking for the similarity of the paper should be more less than 30%. So at that time, what you are doing, are you facing like this?
Okay, good question, and very, very actual question. So I am answering as a reviewer, as an editor mainly. Yes, this is a problem. A lot of journals are doing this similarity check. And it happened to me also. They say, oh, it's 30% similarity ratio, so you should decrease it in order to be considered. I don't like this kind of treatment. So a serious publisher looks into the paper. I mean, what to do, and I'll explain what I did to save such a situation. And maybe someone else can do this. People, what are doing now? To eliminate this similarity, we, in fixed point theory, we use T or S or U for a mapping. We use X, Y, or U or V for the variables. And what are many doing? Using strange symbols.
Yeah, that's true. This is the fashion.
So to be instead, I simply cannot read such papers.
No one can, sir.
Yes, and this is a solution, a feedback to such kind of journal that ask for reducing similarity. A serious editor and reviewer should look inside the paper. I had this situation. I did not change the notation. They said it's 30 and something similarity, because I had a definition for the article of Murthy, let's say. I had a theorem for another article of Veramani, let's say. And what to do? Believe me, I did the following thing. Instead of stating the theorem, I did some story about this theorem. So I described is this normal? This is not normal. So I did this. I said, Veramani theorem is establishing existence of, instead of stating the theorem. So this, I do not agree with this, but this is currently very, very often for journals. At my journal, I do not like this. If they are used very strange symbols, I simply send back the paper. And I ask, please use common notation in our field. It's easy. After we read 40 years papers in this way, it's very difficult to go to Hebrew, some Germanic symbols to use instead of these letters. So this was the problem?
Yes, sir. Yes, sir. Actually, we are facing also every time facing, and we are fed up. Like
this happens. This is not a solution. This is not a solution.
This is not the solution.
But this sometimes is useful. Instead of quoting the whole theorem, the whole definition, we should describe it. We should say the story of this.
Thank you so much, sir.
So it is losing the interest of the audience also to read such papers.
Yeah.
I used to send back, I am unable to review.
Yes, I do the same. I say I cannot review this paper because I cannot read with these strange symbols.
Yeah, my student comes their thesis, I say that original symbol you come, after that whatever you want you do. Very difficult, strange symbols. Yeah, any other question?
Yes, sir. So my question is related to a basic concept, sir. We study function, mapping, functional and operator. Are all are same, sir, or different?
Okay.
Map, function.
Okay. Functional should be considered. So, I am speaking about the terminology in our research group. In our research group, we call function just what we meet in real analysis. So, a real function, we say function. In that case, let's say f is defined on an interval, and this interval is in R, or we could be in R n and so on. This is function. When we have the domain space, we have the domain a space of function space, how to say, function space. So a more elaborate space, like in the case we have the continuous, the set of continuous map functions. Let's say x defined on 0, 1 to R. So this is the set of these mappings. So in that case, we say mapping, or operator. This is, in my opinion, the same thing. Okay, functional. Functional, this is classical. So functional means the codomain is R or C, and the domain is some linear space, some vector space. So this is typical. So this is the general way to adopt, but I've seen serious mathematicians telling function a map is not a problem. So it's correct. We can use it, but by tradition, so this is a kind of tradition. By tradition, I'll tell you the following story. In my university, one professor, engineering professor, he used to, in Romania, the marks are from 1 to 10. 10 is maximum, 5 is to pass the exam, and other 5 is the grades. So this is, and he was computing the grade, the marks for students, and he wrote 4.95, not 5. So he did this, 5. How is he was computing this? Sorry, this is not more working. So he was doing this, 495. And to pass the exam was necessary to put 5. No, he was not putting 5. And the same, some years. And the students complained to the dean, to the head of department, look, professor are doing this. And okay, the head of department asked this person, please, why you do not round this mark and give 5? No, this is 495. This is achieved, I put this. And in the end, the university throw him out. So said, you are not doing this, you go out from the day. He was left aside. Really, he lost his position. And then what he did? He started an action in justice against the university. And he won. After 3 years, he won this case. And why? in the Romanian law was written the grades are from 1 to 10. But the tradition, because this is about, the tradition was for 100 years to do this, to round the mark, to round from 750 even to put 8, from 860 to put 9, and so on. And in the law was written now. Now in the law was changed. This, and the law is now, it will be integer. So, but in the meantime he died. So, but he won the case, and he got back all the salaries for 3 years. The university had to pay him the salary. So this is tradition. This in the context. Sometimes we say by tradition some terms, but important is what is behind this.
Functional analysis, book like Alma, some cases, operator means bounded linear operator, continuous linear operator. Subspace means closed subspace. That is, they follow that, because their interest is only that. Operator, we don't just for any function, only bounded linear. That is just convention.
No, normally, normally at a school level, up to 12th, we talk about the functions, because we talk about the sets, right? And once we start learning the group theory, linear algebra, then we start about the transformation. And once we enter into the this metric spaces and functional spaces, slowly in operator theory, we start, the same transformation is transformed into the operators. This also. And many times the students, they ask that why this is called a functional. Whenever I teach the course and I start with the non-linear spaces and their properties, till reaching the bounded linear operators, I will not say this is functional. These are all the basic requisite to know the functionals. And once you start the functional, means it is in your school term, it's a mapping. But here your domain is a space, and your codomain is a set of real numbers or a complex number. Then only this is a functional. And ultimately from here onwards, you have the applications, because already you are learned the linear algebra. So your applications comes to be the matrices. And matrices, as professor know very well, that in machine learning, matrix is very, very important. Everything is matrix. We have to fix everything in the form of a matrix. So you have the applications also, transpose, then conjugate, all such things comes. So that's why the learning, this is today, but you have to make use of the pen and paper to explain yourself. Not you are going to write some exam. You are trying to, professor always says that we have to explain ourselves first, what the terminology mean. That is very important. And really in many journals I used to write, please remove this one. I was dead against this similarity check and other things. You feel that, okay, he copied and no citation, reject the paper. Ask them to cite the paper. If they are citing properly, they are not doing any injustice. If there are many people, they do injustice, they simply borrowed the idea of the others and writing the paper and without mentioning the references. That is wrong. This is the plagiarism. Plagiarism is a good word, but the similarity is a problem. In similarity, really very, very difficult. Using some new kind of terminology, some functions also now these days, xi, delta, these are new functions now these days, in place of S and T, F and G. So very difficult. Okay, any other question?
Sir, to prove fixed point, mostly first we prove that Cauchy sequence is convergent. So what other, for other ways, what are the other ways, and for that, what literature we have to study?
If, for example, I told you for non-expansive map, we use Jones lemma. Like that many others.
So this constructive way to prove fixed point theorems works for a few, or okay, in metrical fixed point theory, almost the great majority is, but in non-expansive, even in non-expansive, which is metrical fixed point theorem, we cannot use strictly this. There are proofs which are non-constructive. So sequence of approximation is constructive proof. We take the sequence, we show it's Cauchy, but this not work. Even I mentioned Caristi fixed point theorem is in this class. Is not proved using the sequence of successive approximation. And okay, it is very convenient, and the proof, the initial idea, I told you, is from Picard. Picard did the first one, this sequence of successive approximation, and Banach just transposed in the linear norm space. So this was, so it's a strong, I like these constructive constructive proofs, but some of the main results, topological fixed point theorems, which are very useful in a lot of cases where we cannot apply this fixed point theorem, are not constructive, are not proven with the sequence of successive approximation. We cannot prove because the assumptions are different. Yes, because we don't have sequence. We cannot exploit this metrical. We have this metrical condition, so it allows us to construct this sequence. Otherwise, we cannot. Show. Yeah. This is fundamental also. So this is the all right.
Sir, actually, I have one more question to Viramani, sir. Sir, we are talking about the topology about the space. So what is the meaning of topology? About the space. Yes, sir. What is the meaning of topology about the space, and how we can understand this is the topology, and it is not creating topology, it is having topology. Everybody says, but I need some explanation, sir.
No. Generally, if you have a non-empty set, some collection of topology means you have collection of neighborhoods.
Okay.
I mean, don't even right now don't. Ultimately, collection of neighborhoods. That neighborhoods have some nice properties. Then we call it is a topology. Collection means what? That neighborhood is say that. That's what we say that capital X, a non-empty set, tau, a collection of subsets of X. That tau is going to be our collection of neighborhoods. Yes. See how it came. Motivation comes from R2. In R neighborhood means we know center at X, some radius, open interval X minus R2, X plus R. We want to generalize just a set, see neighbors. We understand what is who are all my neighbors. So here these are all, to me, around these are all my neighbors. Like that we have a collection of sets. That collection will become neighborhoods. Then that collection, for that, to have some nice properties, closed under arbitrary union. Arbitrary. Meaning is, you have any collection, script F, a sub-collection of the tau. Then the union of A belongs to script F also in that same collection tau. Then finite intersection. Yeah.
Question of Dr. Ruma is related to the metric.
Metric, that's what metric will see. Every metric space is a
Topological.
How to define an open set? Every point, empty set is open. Even using the definition, capital A a non-empty set. When we say it is open, each point is a interior point. X belongs A min, that's why there is a neighborhood. Balls under at X radius are completely contained in A. Then we say it is open set.